Summary. Ideally, a rigid body is one for which distance between different particles of body do not change, even though there are forces on them. Second, a rigid body fixed at one point or along a line can have only rotational motion. A rigid body not fixed at some way can have either pure rotation or combination of rotation plus translational. Third, in rotation about a fixed point, every particle of a rigid body moves in a circle which lies in a plane perpendicular to axis and has center on the axis. Every point in rotating body has same angular velocity at any instant of time. 4. In pure translational, every particle of a body moves with same velocity at any instant of time. 5. Angular velocity is a vector. Its magnitude is omega equals to d theta by dt, and it is directed along the axis of rotation. For rotation about a fixed axis, this vector omega has a fixed direction. 6. The center of mass of particle is defined as the point whose position vector is r equals to sigma mi ri by m. The angular momentum of a system of n particles about the origin is tau equals to sigma ri fi. 8. The moment of inertia of a rigid body is defined by formula I equals to sigma I equals to 1 to n mi ri square. The kinetic energy of rotation is k equals to half I omega square. 10. Rotation about a fixed axis is directly analogous to linear motion in respect to kinematics and dynamics. 11. The angular acceleration of a rigid body rotating about a fixed axis is given as I alpha equals to tau. If external torque is 0, the component of angular momentum about a fixed axis I omega of such rotating body is constant. 12. For rolling motion without slipping, VCM equals to r omega, where VCM is the velocity of translation, that is center of mass, r is the radius and m is the mass of body. The kinetic energy of such rolling body is the sum of kinetic energy of translation and rotation, that is k equals to half m VCM square plus half I omega square.